Welcome to the demo of Enterprise Secure Coding with AI. As development accelerates with AI, the risk compounds. Faster code generation without embedded guardrails increases exposure unless security and governance move earlier into the workflow. IBM Bob shifts security left by embedding it directly into how code is written and reviewed, ensuring speed and safety scale together. It catches issues while code is being written, prevents credentials leaks before they happen, and embed governance into workflows like permissions-based controls and required human approvals. And by integrating it with HashiCorp Vault and MCP Gateway, automates secrets management and policy-controlled access to enterprise assets. But how would you implement it at enterprise scale? This diagram illustrates how you can implement secure coding in an enterprise environment using IBM Bob, HashiCorp Vault, and MCP Gateway under the governance of your security team. The process begins with the security team, which configures secret engines and access policies in Vault and defines use case scoped virtual MCP servers in MCP Gateway in coordination with the solution architects. These virtual MCP servers expose only the approved Vault tools required for specific development scenarios, ensuring least privilege and preventing risky operations. Next, the security team creates a custom secure coding mode in IBM Bob. This mode embeds enterprise security rules, secret handling standards, and approved integration patterns. The mode is then published to an internal marketplace or source control repository, for example GitHub Enterprise, making it centrally managed and version controlled. Developers pull this secure coding mode from the internal repository and install it in their Bob IDE. Once installed, Bob operates within enterprise-defined guardrails, accessing Vault only through the governed MCP gateway layer. Let us see this in action. This is still extremely common in enterprise apps. Developers hard-code credentials. This leads to secret sprawl, security breaches, and compliance violations. Traditional tools detect issues after the fact. What we want is AI that prevents this during development itself. IBM Bob acts as an AI coding assistant that can detect vulnerabilities, explain risks, and fix them in line. My organization's security team has configured Vault secret engines and Vault MCP server. Together with solution architects, they also identified required Vault MCP tools for the secure coding use case and created a virtual MCP server, secret sprawl resolver with required tools only. I have also imported secure coding mode that has been created by my organization. I have also subscribed to Secret Sprawl Resolver virtual MCP server hosted on MCP Gateway that only exposes required Vault tools for secure coding use case. Now, let me ask Bob to scan this existing repo for secrets. I would just say it to scan the existing repo for secrets and replace with Vault secrets. It has completed scanning and presented me the options how I want to proceed. Let me ask it to migrate all secrets to Vault and update the code. Bob proceeds with the steps from the to-do list that I approved. It identifies which MCP tools to use. As I have enabled auto approval for MCP tools, it continues to leverage the approved tools as per need. Bob does not directly access Vault. Everything goes through MCP Gateway, ensuring secure, auditable, policy-controlled access. It takes few minutes to scan the secrets and move them to Vault. It also updates the code to access the secrets from Vault just in time. At the end, it creates comprehensive documentation along with the summary of the changes made. This is how enterprises move from experimental AI to production-grade secure agentic systems, where AI doesn't just generate code but enforces security, compliance, and best practices by design. Thank you for watching the demo.